Hello, everyone. We are going to be doing the 9.2 notes for today. We are on page 283 here in that student journal. We're going to do 9.2 in class both days. It's short enough that I'm doing it on A day and B day. But just in case someone is out or we need to go back later and just refresh our memory, I am going to post a video for 9.2. The good news about 9.2 is it's really pretty quick. It's pretty straightforward. Once you know kind of what you're doing with these graphs, it's pretty simple to solve. This is what we're doing today. We are solving by graphing, which sounds like it could be maybe kind of involved or take a long time, but the good news with this is I'm not going to ask you to graph yourself. This isn't going to be like chapter 8 where you'd have to come up with all your points and put something on, graph paper. I'm going to either give you a graph or I'm just going to have you graph on Desmos for this chapter, or for this section, I should say. Okay, so let's grab that vocab there for quadratic equation. So quadratic equation, a nonlinear equation that can be written in this standard form, ax squared plus bx plus c equals 0. So this is really similar to what we've been graphing, right? The only difference between this and standard form of these functions that we've graphed, so our functions look like this: ax squared plus bx plus c equals y. A or y equals all that stuff. The order doesn't matter, but we're used to seeing it as y equals. So really what we're doing, we're going to be given this equation that's only in terms of x. And we can say, oh, well, if we just set this equal to 0, we can graph this function right here and think, okay, well, where does y equal 0? Okay, so think about where on a graph y is 0, and it's just right along that x-axis, right? So really what we're doing when we're solving by graphing, all we need to do is just find our x-intercepts. As long as you do that, you're going to come up with the right answers for these. This is really just not trying to trick you. We just want to make sure you understand that when you look at a graph of a quadratic, the solutions to that equation are your x-intercepts. So there's a couple different things that we can find as we do this. There's a couple different options as far as how many answers you're going to get. You could get 2 real solutions. So that would look something like this. You've got your little parabola, and it crosses in 2 different places. Okay, so you'd get something like, I don't know, x equals 3 and x equals 6 on this one if I was guesstimating. Right? We can get just one solution. Okay, if the vertex of our parabola is just right there, that's the only part that crosses. It doesn't cross in 2 places, it just crosses in 1 place. So I could just say, oh, this is just x is equal to -4. Okay, so I can have 2 answers, I can have 1 answer, or I could have something that looks like this. Right, where it doesn't cross that x-axis at all. I don't have any x-intercepts. So in that case, this is just no solution, no real solutions to this problem. All right, and I say no real solutions because we have imaginary solutions, but we don't really get too far into imaginary numbers here. You'll get way more into imaginary numbers in Algebra 2. All right? So these are our 3 options. You're either going to have 2 answers, 1 answer, or you're going to say no solution. This graph doesn't ever cross my x-axis. Right? So I'm going to show you a little bit. I don't love the examples here in the student journal, so I'm going to show you in the textbook some things that kind of look like our homework. All right, so over here, you'll get something like this. You'll get a little image of a graph. It'll say, okay, in this equation over here, it gives you this equation. Tell me what my 2 solutions are, or 1 solution or no solution. You'll just look and you'll see your 2 little x-intercepts, And you'll say, okay, great. I have x is equal to -3, and I have x is equal to 1. That's all there is to it. You don't need to redraw the graph in your homework. I just need to see that you know you can look at a graph, find those x-intercepts, and you know those are the answers. Okay? Don't go crazy. Don't tell me the vertex. Don't do anything like that. Just tell me the x-intercepts of that graph. All right, let's look over here. I want to, it's just going to write now. Hold on. All right. So I have, over here I have another one where I can see I only cross that x-axis in one place. It's just right here at this 4. So my answer for this is just going to be x is equal to 4. Okay, so I can have 2 answers, or I can have 1 answer, or, oh, where did it go? Somewhere, there we go. I can have something that looks like this. We see that this doesn't cross that x-axis at all. So over here I have a problem that has no real solution. You can say no solution, you can say no real solution. They both really mean the same thing. You can also go back to this symbol if you remember that from earlier this year. All of these really mean the same thing, so that can be your answer for any of these. All right, so that's how you solve them when you have a graph that is just giving you. Sometimes it's going to ask you to solve some of these yourself. So I want you to go to Desmos. If you've used something like GeoGebra or you have a graphing calculator, it doesn't really matter. It's all the same thing. But I'm going to show you on Desmos. Let's start. Let's do this equation right here. X squared plus 2x plus 4 equals 0. Okay, so I'm going over here to Desmos.com. I have it linked in the homework as well. Hit graphing calculator because that's what we need. Alrighty. And I'm going to have x squared. I may have to use my little keyboard here, use this to find our squared plus, what was it? X squared plus 2x plus 4. Okay, plus 2x. Okay, I don't need this. Go away. Plus 2x plus 4 is equal to 0. Okay, x squared plus 2x plus 4 equal to 0. It doesn't always love being put equal to 0. We're graphing, so we can either just leave this on its own or set it equal to y. Right? That's really the same thing. Okay, so either x squared plus 2x plus 4 on its own or equal to y. We get the same thing. On this one, we see we don't have any x-intercepts. So we know this one is just a no solution. This is the one we've looked at earlier. All right, a couple more. Let's do this one over here, our x squared. Oh, I didn't want that to happen. It was x squared plus 2x is equal to 3. X squared plus 2x equals 3. And I know this looks like a parabola. It's not quite right when we just write it out the way that it's written. We see the problem here is that you have terms on both sides of your equal sign. You're going to have to do a little bit of algebra, and you may have to do this on your paper as you're working. You're going to have, let's see over here, let's get my pen. This x squared plus 2x equal to 3. You want to move everything over to one side. You're going to subtract your 3 over here. You want to equal to 0. X squared plus 2x minus 3 here is what you want. Otherwise, the graph is not going to be quite right. So let's put, I've got too many things up. 2x minus 3. That's our correct graph there. Again, you can put equal to y. It doesn't change anything. All right, so you may have to do a little bit of algebra before you can throw it into Desmos. But Desmos is going to be the most useful. And actually, if you hover, it'll show you these values as well. Okay, -3 and 1 would be my two values. So my final answer on this one, x equals -3, x equals 1. Alrighty, we're going to do 9.3 on Monday. Make sure we understand that. Our quiz is going to be on 9.1 through 9.3. That's going to be Tuesday and Wednesday of next week. All right, I'll see you guys later.